Okay, wanted to go through a couple quick examples. Here's the first one. So you can pause this and scrutinize any of it without the wild panic of your classmates or myself, or perhaps even yourself. First off, some of you missed that maybe this can be written with exponents. So hopefully this is pretty obvious. We got two factors of x minus 1. We have one factor of x plus 3. And we have 3 factors of x plus 2. So we would call this one, this one has multiplicity 3. Multiplicity, that just means it repeats 3 times. Factors are multiplied. Multiplicity 3, which of course is odd. And this one has multiplicity 2. So that has even multiplicity. This one doesn't have multiplicity. Or you could think of it as having multiplicity 1 to be thorough and complete. So we want to identify 3 things. First off, the x-intercepts. And the whole point of factored form is that x-intercepts are easy. They're 1, -3, and -2. We've already identified multiplicity, and we'll use that in a moment. We also want to identify the y-intercept. That occurs when x equals 0. So we go back to our equation and put it in x equals 0. We're multiplying these numbers. So we have 1 times 8 times 3, which is 24. So the y-intercept is 24. We also have to identify it's what your book is referring to as end behavior. That's where the little arrows go in the end. But we're also calling it what's the degree of this polynomial, and the degree of the polynomial should obviously be 6, which is even, which means it's got to go like that and that. So let's graph all that stuff. And scroll up here. You'll have to rewind if you want to see any of that information. I'll keep the x-intercepts there. So I'll make a quick sketch here. We're not going for hyper accuracy. We just want to get the relevant information. So I'm going to make a scale where each one of these is 1. So 1, 2, 3, 4. 1, 2, 3. 2, 3, 4. We've got an x-intercept at 1, an x-intercept at -2, an x-intercept at -3, y-intercept at 24. We know it's even, bloop, bloop, and we know that it's got multiplicity even right here. That means it's got a bounce at 1, which makes sense because it has to come up here and get this y-intercept, then it's got to come down here. At -2, it's got multiplicity 3. That means it's going to do a little fake. Pretend like it's going to bounce, but not bounce. So that even multiplicity gets this kind of result, odd multiplicity gets this kind of result, no multiplicity just plain old goes right through it. And there's your graph. Again, it won't look exactly like this on the calculator, but it'll look kind of like this. So what we're trying to do is go from our equation in convenient factored form to sketch what we believe the graph should more or less look like. We're making a connection between the equation and the graph. Next step, factoring.